Okay, are we live? Just gonna give it a minute. Okay. Can you guys hear me? Okay. Well, I'm probably gonna cut out the start of this stream when I put up the video, but I guess I'll just get started. Alright, so I'm gonna explain what I'm doing. So, today we're gonna be building a string builder. What is a string builder? A string builder is, it's not exactly a data structure. It's a thing, I don't really know what you would call it, that allows you to construct strings out of other strings. So you can do things like build, let's say string builder, you want to add some numbers into your string. You might want to add some U32s or something. Put some numbers in here, and then you could add them into your string. Why do you need to do this? Well, because in C and other languages you can't just add strings together like you can in Python or JavaScript or something. So we need to actually build them. So my idea is we're gonna basically make a new file here. And I'll call it string builder. Actually, we should make strings first. So we need to make strings before we can make string builders. So I'll call this string or strings, doesn't really matter. Okay, in C, the default string type is a character pointer, but we don't really want to use that. So what we want to use instead is something like this string. We're going to call it a string 8, so it's going to be a UTF-8 string. Well, actually, it's just going to be bytes right now, but that's the hope for the future. Okay, and it's going to be made from an array of unsigned characters, which is a U8, and that'll be our buffer or data, and then a length. is going to be an unsigned 64-bit integer. Now we want to include our types here. Okay, now the thing about strings is if you build them like this, you don't need to add the zero termination at the end, the null termination. So if you don't know about C, basically if you make a string like this, blah blah blah, then actually at the end of this is going to be an invisible null character, and that's to tell when the string actually ends. And so we don't need to do that, but I am going to still actually have that in the string, I think, because that way you can pass it to functions like any Win32 functions that we use, and we'll still get the null terminator at the end correctly. So what do we need to make strings? I usually like to define a macro, something like this, where we can pass in a literal, and then we'll get back basically one of these. So and there's a macro for this called I can't remember what it's called actually. So I'm going to leave that for now. What else do we need? We can't use strlen, right? Because that's part of the standard library, and we're not using that. Okay, we'll come back to this in a second. Okay. I don't know why, but I'm really nervous. So I'm just going to change the current task here. String baby is asleep, making a string type. Yeah. So I think the size of, can we look up size of somehow? I want to find out the exact characteristics of it. Okay, is this helpful? Oh god, it's so bright. Let's see. Size in bytes of the object representation of type. Size in bytes of the object, blah blah blah. Okay. This is C++ stuff. I'm pretty sure you can use this to count the length of a string. Possible output, size of empty class, pointer, array of 10 ints. Okay. Size of, what is a cha-cha? What is that? I have no idea. All right. Let's see if we can do some experimentation with this in main. Okay. So we can get size of. Okay, what's this going to return us? Suspicious usage. Did you mean Sterling? No, I didn't. What does this return? Did it say what the return type was? Size of expression is always blah blah blah. Is it a size T? Yeah. Okay. Size T. Okay. So it's, does that work? Yeah. I want to see what this does. And I want to see what this does. And what this does. So maybe you can learn something. Okay, apparently running, but didn't break. Okay, there we go. Okay, go again. Not running. Huh. So this is all because it's constant, so we don't get to look at it. Is that right? That doesn't make sense. Why did this not go off here? Yeah, okay, there we go. Size of this is a pointer, looks like. Okay, size 2 is 1. That's what I would have expected. Size 3 is also 1. Well, that's not very useful. This I can't use. It's provided by string. But maybe we can look at it. Oh god. What is this? Okay. Windows code. Copies a string. Wait, what? So this is a macro that copies something. What is this? This is not good. Okay. Hang on a second. What if we make a U8? It's going to be exactly the same problem. Size of array, size of hang on a second, we got a 5. Hey, this one works. Okay. Interesting. Right. Okay, so we can count that. What about string to what about this? Size 6 is 7. So it included the null terminated 0. Okay, this is gonna work. Alright, there we go. So, why did I do all that? Because I didn't want to look it up. Trying to figure stuff out from experimentation. So, that means if we pass in a string literal here, we can use size of literal minus 1. I think that will work. Yeah, let's have a look. We'll make another string. And we'll call it 1, 2, 3, 4, 5. I need to include the strings. Do I put it in the header? No, C. Undeclared identifier. Oh, that's weird. Oh, right, didn't change the include guard. Okay, what was that? I didn't read it. Initializing yeah, that's fine. Alright. Hey, Josh, how you doing? I am making a string builder, but first I need to figure out how to count strings, and I've just figured it out. Looks like. Let's have a look. Where is it? Too many strings here now. Here we go. My string. 1, 2, 3, 4, 5. To length is 5. Great. Okay. First step done. We can make strings that are a little bit more sane than C strings. Now we need to decide how to make a builder. So I'm probably going to make it into a type string builder. Because it's going to need to hold some state. So I'm thinking it'll have allocator, which would be the scratch allocator. So this is going to be where it puts data while we're building the string, and then it can just delete it afterwards. Or the user can delete it. So I need some memory stuff. How did I do that? Okay. And probably don't need to pass in another allocator, because we can pass it into something like, we probably want to use it like this. String builder equals string builder init or something, and then pass in an allocator, and then we say I guess string builder append, and then we pass in the builder and we pass in what we want to append. So we could say something like this. Something, and then we could append something else, and then string builder. I don't know, I've never actually used a string builder, so what would you call it? Finalize, done, finished, end, whatever. Let's just call it done for now, and we pass in the allocator that we want to actually use. So let's say we make another allocator. Why don't I just copy this? So make another allocator here. It'll be our permanent allocator. Okay, it's going to be 1024 bytes. That's fine. Whatever. Doesn't matter. Okay, so we have an API kind of like this. So we want to append some strings and then say we're done. I also want to be able to put numbers into it. So, like, I don't know how we're going to do that. I'll think about it later. Let's just get this simple version working first. So we need to initialize. And the initialization is just going to be some kind of state on a struct, I think. So we'll have like a current offset, which is where the string is up to. No, length, probably length. Buffer bytes. Yeah, okay. So the thing is, I don't want to do complicated memory stuff. So what I want basically is for the user, they're not going to know what they're going to build, maybe. It'd be nice to have like just a buffer that's big enough. And then we'll just build it like that for now, first. So what am I talking about? Well, we need somewhere to put these strings as they're coming in. And that's probably going to require using a scratch allocator. And then we're going to string them together. Yeah, so maybe we'll have a list of pointers, I guess. That could work. String builder init. So this is a scratch allocator, which means we're going to throw it away, but, well, we're not going to throw the allocator away, we're going to throw the throw the data away later. Yeah, it's comic mono. I actually really like it. Maybe because my age. Excuse me. Alright, so we're gonna make an allocator, not allocator, string builder. It's gonna be the result. And what are we gonna do? We're gonna add the scratch allocator. Buffer bytes. So we need to allocate some space here. We're probably gonna use the scratch allocator that we just sent in, and this is going to be maybe we don't need to use the scratch allocator. I mean, maybe we can actually build the string as we call functions onto it. So if we pass in another allocator here, well, the problem is we don't know the length. That's right. That's why. Okay. Yeah. Because our allocators can't guarantee contiguous storage, well, they can, but then it's an arena, so it's going to keep wasting tons of space, which might be fine, but that's why we're using Scratch for it. So what we're going to do is make an initial size. Let's just say 256, just a random size. What's the problem here? I'm assigning to a U size. Oh yeah, this should be a U8. pointer. And the length is 0 at the moment. Okay, so we've got our space. We're going to build our string into this space as much as we can. Okay, so we need to build this. I'm just going to make a void. Maybe you could return some interesting information. Don't know. We're going to pass in the string builder. And rather a pointer to the string builder. Because we're going to need to update it. And then some kind of string. So, pending. Yeah, I've never built one of these. I've also never used one. So I'm just kind of guessing as to what this is going to be like. So let's say pass in a string. We want to increase the length by the string length plus 1 because no, actually just by the string length. So we'll do that at some point. Sorry, I'm just checking the baby cam. All good. Okay. So we'll do that at some point. And what are we doing? Appending a string. So we've got a current, we've got a buffer and a length. Okay, we need an offset. Or, yeah. Which is how far into this buffer we currently are. So that means this length should actually not be increased. And we should increase by string length. And we want a memcopy. Memcopy, by the way, is an intrinsic in the Microsoft compiler. So we're not using the standard library, but I can't override this unless I make my own function like mem underscore copy, or I think I can tell the compiler to use my functions instead, but I'm just going to use the intrinsic. That's fine. Okay, so we're going to copy into buffer plus offset. And we're going to copy the string data. And we're going to copy that much of it. Okay, that's pretty easy. Then we move the offset up. We increase the length. So you can see this hard-coded length here is going to be a bit of a problem. But that's fine. Let's just test it first. Okay, let me call done. Now we can't pass this in apparently. What's the problem? Initializing U8 with unsigned. Oh yes. So this macro needs to change to, I think this. Is that right? This needs to be pointer. And let's make this function now. Ugh. Alright, so we're going to have to call on the actual builder. So I should definitely change this. And we want an allocator that we're going to build the string into. So we'll call that the permanent allocator. Okay. So basically what I'm thinking is we're done. So we can just say make U8 builder. Well, I should probably return the string. So we're going to make builder length and use this allocator. Return result, which I haven't made yet. And this can actually just be result.data, result.length equals blength. Yeah, so I'm going to actually add an extra length onto here to have a null terminator. So my allocator is 0 memory by default. So if we go down here, actually we're turning it into 0xbc. So let's turn this into 0 by default. So that'll automatically be null terminated. Okay, length is length. Yep, that's right. So I think the way I want the strings to work is, even though we have the length, I'm still gonna add the 0 onto the end. Okay, now I need to copy the data. So basically we're doing another copy here. Whoops. We're copying buffer bytes. Okay, so let's have a look and see if our test works. I'm sure I forgot something. I should have just put a breakpoint a bit lower. Actually, you know what? I'm gonna comment out a lot of this stuff because it's filling up the window. I'll put a debug break here. Okay, next one. Here we go. Cool. So, B. Okay, that's good. We've now appended something to here. That's good. That's what we wanted. And we've appended some numbers. That's good. Is that 23? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 21. Wait. 1, 2, 3, 4, 5, 6. No, 9. 18, 19. That's still wrong. 18. 22, 23. Oh no, it is correct. Yeah. Great. And then, okay, what did we get? Oh, I didn't save the value, but it should be in the permanent arena here. This debugger is called rad dbg. Well, our offset is 1, which means that definitely didn't work. Interesting. Let's have a look. What was the length? Okay, let's step into that this time. What do we got? Result. Length is 0. Oh, well, that's not great, is it? Yeah, I never set the length, did I? No. Actually, I don't need length. What am I doing? Yeah. Well, actually, it makes more sense to have length. Okay. Okay, length gets incremented now. Okay, what do we got now? Length is 23. Copied something into here. That's good. Return the result. That's great. Now if we go to this buffer, memory address. Oh, it's there. Did you see that? think there's a bug with the display right now. It's like flickering. So if I scroll, you can see it for a split second. Maybe not coming through on the video. That's kind of annoying. Okay, I really like this debugger, but I think I'm gonna use Remedy BG for a minute. What are we doing? Base layer. Okay. Let's have a look. Alright. Good, 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 good. Okay. Now if I look at permanent arena. I need to go to the buffer. That's the stack. There we go. Alright. Something, something, 1, 2, 3, 4. Fantastic. I agree, Mario. That's actually why I'm using Windows, mostly. Because there's the RAD debugger and there's Remedy BG, and unfortunately on Linux, I mean, people will argue with me about this, but I don't think there's anything as good as these. Plus also I like doing games, and 98% of people play games on Windows, so it just kind of makes sense to use Windows. I mean, on Steam I'm talking about. I should probably clarify that. 98% of Steam users use Windows, even though the Proton is really good. You can play games on Linux. People still aren't really switching over. Oh, I switched just now because there was an error with the memory watch window, the memory window. So it happened in my stream earlier today as well. I couldn't see bytes that were in here until I scrolled like just off the screen, and then it would flicker on for a second. So yeah, I need to tell Ryan about that. I'm just going to put Remedy up here for now. Okay. Yes, in my experience, yes, most Linux debuggers are front ends for GDB. There was some that I was looking at, like RR. It's like a debugger where you can record everything and play the program backwards and forwards, which is pretty cool. But I was having a hard time getting it working. There was Code Clap, which I think was another handmade project, or maybe I bought it on itch. I bought that one, I tried it. It's pretty good. Stream audio is low. Again, is that better? I'm just trying not to wake up my daughter. Maybe I have something in the settings here. That's not input. Okay. That's really weird because my OBS is maxed out. Maybe there's volume knob on this thing? Yeah, there is. Let me see if it does anything. Yeah, I don't think so. I think that's for the headphones that you can plug in. I'm not sure what I can do about that. That's not good. Audio devices. Well, not Audacity. God, Windows is garbage. Yeah, why is there no like microphone? There we go. Okay, is that better? Is it good or should I crank it? Okay, great. I'll just put it at 80. Alright, thanks for letting me know. I really hate that. Yeah, when I record videos, I have to always increase the volume by tons. So I guess that was why. Okay, so we got a string builder working. It's not the most elegant thing. We can only build... Yeah, I've seen that, Mario. There's so many volume controls on Windows. There's like 5 different ways to change your volume or something. It's just crazy. Okay, this is kind of cool. It does do, you know, a mem copy, and it only goes up to 256 bytes because this is hard coded. So that's kind of why I wanted to experiment with something a little bit different. What could we do? We could say something like, I mean, we could build a custom allocator just for the string builder, but then the user can't use theirs. We could also, I'm thinking we could have an array of pointers, basically, or an array of pointers and lengths, and then keep that instead of copying the data. But that might be a bit of a problem if you pass in a string literal like this, right? That's going to disappear when this goes out of scope, so we can't do that. At least not if we want to keep the same API. I don't have a particular problem with... Oh, actually I have another idea. Okay. What if every time we append something, we actually allocate space for it? So we make a buffer, and we put that in the scratch allocator, but we have access to the scratch allocator from this pointer here. Okay, and then we copy into this buffer the data, and then increase the length. That's all good, but now we have to get this buffer back at some point. So how do we do that? Well, we could say keep... This is what I was talking about, keeping an array of pointers. So if we have an array of pointers to U8s, array of pointers to U8s, and this could be strings, I guess. Buffers, I don't know. Strings is fine. We don't have lengths though. Well, we could also allocate lengths, or these could be, yeah, this could be a pointer of string 8. So my thinking is basically we allocate these as we go into the scratch buffer, and then at the end we construct using this array, which would be indices and lengths into the scratch buffer. And then we don't have to use this. We don't have to have a buffer with bytes. I like to make assumptions like the programmer knows specific things, but the programmer probably won't know how long the string is going to be up front. That's why this is a bad idea, unless we just allocate tons of space. And then just say, look, you can't have a string that's longer than 4 megabytes or something, but then you couldn't use this to build like a binary file. It wouldn't work. And I want to do that, so we can't do that. Grow the buffer if needed when appending. Well, the thing is, the current allocators, I guess we could. It would waste a lot of space in the scratch allocator. What I was saying was the current allocators don't grow, so they're fixed size. That's why I'm trying to think of a way to get around this. Yeah, I think it's just one of those situations where we have to make a growable allocator. Yeah, most strings won't be that long. That's true. But I want to be able to use this to just build arbitrary binary data. So, you know, later if we get to it, I want to make like an image format, and then you could stream, you know, the pixel data into the encoder and then put it into this string builder or something. We could use it to build arbitrary file formats or whatever. But yeah, an interesting problem. I think we're just going to have to be able to grow. Copy the whole allocator to a new, bigger allocator. Incrementally. Oh, I see what you mean. But then that means the string builder itself would be allocating memory using the operating system, right? I kind of don't want that to happen. I suppose we could just say, you know what, the scratch allocator needs to be big enough. It needs to be big enough to allocate whatever it is that you're doing. I think that's fair enough, isn't it? And then that way, it's up to the user to pass in a giant scratch allocator if that's what they need. But it does mean the scratch allocator needs to be able to grow. Sorry, not the scratch allocator. It needs to be able to reallocate, which currently it can't do. So if we look at the memory file here, the arena allocator, it allocates if there's space, otherwise it just returns nil. Right? So there's no reallocation going on. What else could we do? Thinking. Okay. If we do store an array of pointers, then that would also be limited as well. Oh, you know what would be a perfect data structure for this? Well, not perfect, but it would work. I think a linked list would work, which is kind of funny. A linked list, because then it can be arbitrarily placed in the scratch allocator, and we wouldn't have to reallocate. And assuming that the person is building the string like, you know, in a loop or something, or just, you know, like this, you know, you usually start your string building and then you finish it. You don't like start building a string and then go off and do a bunch of bajillion different allocations and then come back and finish. Well, you might, but assuming you don't do that in most cases, then the linked list nodes would all be pretty much contiguous in the arena, which would allow this all to work, because you could use the next pointer to find the next string until there's no strings left, and that would be what you're doing here. Wow, what do you think? Linked list? Should we do it? Alright, I'm gonna do it. I'm gonna take your silence as consent. Wait, that sounds wrong. I'm gonna take your silence as acquiescence. How about that? Yeah, that's a good point, Josh. And actually, I think what we might want to do... Well, actually, we've given them access. So the user can see here the length at any point in time. So after they append, they need to ensure that b.len is less than space in permanent allocator, basically, right? Alright, what we're doing, we're making a linked list. Man, I haven't made a linked list in a long time, and I never thought I would need to use one, but it just makes sense. Linked list defined. Should a linked list have a linked list struct? Or should it just be a node? Growable allocator? Yeah, I kind of don't want growable allocators though. I know that sounds crazy, but I just want to see if we can not do that. Linked list. I guess we don't really need a linked list type. Well, maybe we could have one. We could have a length. We don't. Usually, you don't have one, but I don't know. Let's see. I'm gonna design the API for it first. So basically, we would have. This is totally wrong now. List, append, we'd append to the list something, this thing actually, this buffer. Actually, we'll probably make this into a wait, what am I doing? Need to do that here. Something like that. Okay, so we want to append to the list, yada yada yada. Alright, pass in our data, and increase the length. I guess, yeah, we should keep this length updated so the user knows how long the string is going to be. And then I guess in here, we still want this and this. This is going to be different. So we're going to have to iterate through a linked list. Thoughts on a global string builder that obviates the need to pass in a scratch allocator at all, give it a massive internal size, and underscore done resets its own allocator. Yeah, I guess that sounds pretty fine. Guess it depends on your program and who you're working with and stuff. No, that's okay. Thanks for the suggestion, Josh. Yeah, that's a pretty cool idea. I like stuff like that. You know, simple, making assumptions about things. A lot of people program like the programmer doesn't know anything. It's really weird. I find it kind of annoying. Like, oh, the programmer might not know this, except they do. Like 99.9% of the time they know the thing, whatever it is. Alright, what was I doing? Oh yeah, iterating a linked list, great. I guess we'll just call it linked list node. God, I hate this. What is a linked list? It's going to be a pointer to data. Yeah. None of this has to be final. I gotta remember that. So we're just gonna point to some data, and we're gonna point to next. Actually, oops. Yeah. C has a bit of a few annoying things. So this should be struct list node. Okay, now we can do this. List node next. Great. I don't think we need to have this. Do we? No, probably not. We'll just keep track of the head of the list. So list append. Do we want to return a pointer to the node? I don't know. Let's think about it. Maybe instead of append we say insert after. And the reason is because if we say append, are we appending to the current node that we're going to pass in, or are we appending to the end? I mean, I would think the end, but this node next equals, oh yeah, we also need to pass in the thing, whatever we're appending. Why do we even need a function for this? We're just going to do that. We don't need a function for this. This is silly. Okay. Let's see. We're not going to do that. We're not going to have buffer bytes. We are going to keep a length. We're going to keep a list of string nodes, I guess. And this will be... Actually, this can be not a pointer. What's the problem? Oh, I need to import it. What is this? Don't know. List. Linked list. What did I call it? Interesting. Data next. Okay, that's fine. So the head will always be available on the string builder struct result.next string, sorry, equals, I guess this. Can I do that? I don't think I can. I need to do this. I suppose I could just have 0 initialize this one and then done that. Great. Or actually, I could even make this shorter, because the other fields will be automatically 0 initialized. And then I could not even have this function. Whatever. Let's just keep it in case we need to do some other stuff in there. Okay. So we're gonna grab the not result strings while strings next not equal to nil. Actually, what am I doing? Okay, we got our current. I need to take the address. That's fine. While current next is not equal to nil. Current equals next. Okay, that's fine. Okay, now we got to do something. We got to copy into buffer bytes plus offset, which we haven't defined yet. Oh, there is no buffer bytes anymore. Result data plus offset. We've got to copy the current data, and the size is current data dot. I guess this should be data dot data. And we're going to store pointers to, is that right? What did I should just read the error. What does it say? Passing string A to unsigned long. Oh yeah. Wait, what? That doesn't make sense. Ah. Right. Is that? There we go. Okay, why don't we just do this? That's better. What's wrong with this? Oh yeah, no semicolon, there we go. Okay. I think I just disconnected for a second there. Now with the list, we're actually going to keep a pointer here as well, which is node tail. Okay. Every time we append something, we want to say the tail is. Now we have to make a new list node. Actually, it's not make, it's new, using a scratch allocator. But I shouldn't actually do that here. Shouldn't assign that yet, because I'm going to need to set the next pointer on the previous tail. Okay, which means this. Oh no, that's going to stay nil until we append. Alright, let me just delete this. What is this? Copying data into a buffer. That's kind of a problem, because we're storing lengths as well. Okay. We need to also allocate length. No, 1. What's the problem here? Int is not a structure or union. Okay, interesting. What? Int is not a structure or union. Right, yeah. What am I doing? This needs to be scratch. Alright. So we've got a buffer, we've got a length. Copy the buffer. Set the length to s.len. So we can't guarantee that this string being passed in is going to stay around until the end of the building, so we're going to keep an internal copy. And so now we can make our list node. Yay. New list node. And we set the data to... Oh, bloody hell. This should have been a straight. And the buffer is not buffer, data is buffer. There we go. And now we can set this. Data equals string. And next equals, well, it's already going to be nil because this is guaranteed to return 0. So that's fine. Now we've got our node. We can get our tail. We're going to have to check if the tail is nil. So if tail is nil, then we just want to set the tail to this. Else we want to tail next equals this, and yeah, that's right, isn't it? So basically we don't need to have this, we can just do that. I think that's correct. Alright, there's been a lot of programming and not enough debugging, so let's have a look and see where we got things wrong. Yada yada yada. Okay, so we're going to go into the append function. Let's have a look. Haven't used remedy in a while. I don't have variables anywhere. Is that a thing? Yeah. Is there a locals window? No, but that's alright. We'll use the watch window. BS, what else we need? String, buffer, string, this node, I think that should do. Maybe scratch, no. Alright, let's have a look. So we've got our string builder here. It's got a length of nothing, tail is nil, that's fine. Oh, I just realized we didn't set the strings, so we didn't set the head. I should probably call that just head instead of strings. But we'll have to do that in a second, that's fine. Okay, we've made our string. Copied our data into a buffer. Unable to read process memory. Okay. Oh, good. Like this 19. Yeah, that's correct. Okay, we've made our list node here. And points to string, that's good. Tail is not nil. So therefore, tail, that's, can't do it that way. What am I doing? Yeah, that's not going to work, I think. Oh no. Oh no, that's fine. Okay, so we set our tail here. That's fine. We set our length to 19. All good. And then we do it again. But, well, let's just have a look, shall we? Okay, good. Tail is not nil. Okay. So now the tail should remain the same. Which is, where is it? Tail data. Send to memory window. One, two, three, four. Oh no, we're appending. Yeah, we're appending. Okay. So the tail changed. That's what we wanted. Okay. But we didn't set the head, which is a bit of a problem. But if we check out our other one, so it was this one, I guess, with the something in it, something. Well, that's where the data is. This looks like a pointer, right? I can't copy it. Okay, hang on. Let's go and set the head. So if the tail is not nil, then blah blah blah. But else the head is going to be nil, so right. Well, I suppose we'll just allocate it either way. That's fine. What was the error? Yeah, right. Head. Okay, here we go. We should have our head is here. Let's just go through the next function. Blah 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 blah. Okay, let's have a look. Got our head. Got our data. If we go to the memory window, it's here. It's a pointer to 0, 0. So this, it's pointed to here. 0, 0, 5F, 12, 7F, 1. So it's pointed to this, which is something something. That's exactly correct. Great. Okay, and if we look at the tail, or rather, let's look at next. So next is pointing to here. 505F, so it's another pointer to 50. So this is 40, 50 is here. So 4050, and this is a pointer to 40, which is the data. Correct. Great. And the length, I guess, would be... Yep, that length is correct. That's 4. And then the length for the other one, 60 in hex, I guess. Is that 19? No, that doesn't sound like 19. What is this value? Maybe it is. No, this is a pointer. Yeah, I know, right? I really like Odin a lot. But I just got nostalgic for C, and I just wanted to try build some stuff from the ground up. See what it's like. Okay, I think we're good, but no, I didn't even... Probably should have tested the actual building of the string. So let's have a look. The building of the string. We built the string into the permanent allocator. Yeah. You're right about that. Actually, we can just put the permanent arena. Hey, look, in the permanent arena, there's a buffer that says something something. Okay. Interesting. The offset is 24. Which tells me that we copied a 0 into here, I think. Let me have a look. Oh, no. No. We didn't. We just didn't copy the second string. Okay. Because it should be current is not equal to nil. I think that's the reason. Let's have a look. There we go. Something, something, 1, 2, 3, 4. Hey, look, the linked list worked. That's cool. Finally found a valid use for a linked list. And if we look at the nodes, if we can, where are they? They're in this temporary arena, right? That's just called arena. So now temporary arena, if we go to the buffer here, we can see we've got the nodes. They're basically this one, that's a pointer. I think it's, yeah, this one here. And where's the other one? There's so many pointers here, it's hard to remember which one's which. So the strings are here. Anyway, it doesn't really matter. My point is, the nodes are all next to each other in memory, so it's not like the normal linked list problem where you have, you know, one node here and then one node like, I don't know, down here or on the next page or like 10 pages away or whatever. So I think that's totally fine. Yeah, okay. So that's a nice rudimentary string builder that's kind of working. Blah. So we can append strings. What else do you need from a string builder? I want to be able to put numbers in there. Yeah, I was just watching one of Jonathan Blow's old streams where he's building a file format for something, and it made me miss doing binary data, and he was using a string builder for it. So I thought, you know what, it'd be cool to be able to add binary data into the string. Because essentially, they're just, I mean, we could do something like this, string builder, append, I mean, he was using it for like magic numbers, but I think you could actually just use this and you would get the text in, but you'd get it in big endian order, wouldn't you? Let me see. Yeah, let's see, center memory window. What? Okay. That was the stack. That was the struct on the stack. Okay. So if we look at magic here. What is M in hex? Can I type it here? 77. Oh, in hex. Hex is not a thing, is X. 0x40. Okay. So this one, MAGIC. So this is in, I guess, big endian. Hey Niraj, this is not an IDE. This is the Remedy BG debugger. So do we care if the order is big endian or little endian? I don't know enough about decoding data to know. Because I guess if you took, so this is 5 bytes, right? 5 bytes, but if it was 4 bytes, that could be a uint32 number, right? And then if you're encoding some data, or decoding or whatever, and you need a magic number, well, the order of these bytes is going to be totally different. Yeah, but since everyone uses little endian numbers, and well, everything really, I think it should be little endian, which means you need to swap these when you append them, like reverse the direction. I'm not really going to worry about that right now, I don't think. I am going to have a look and see what other string builders do, because I've never seen one. So let's have a look. String, not string builder. Probably not Java. Why would you use a string builder? That's a good question. Maybe we'll look at the Rust one. Why not? Oh god, why is it so bright? Is there a brightness? No? No, okay. Not gonna look at that then. String builder in Odin. I think Odin has one. Yeah, flashbang for real. String builder. A dynamic byte buffer / string builder. So I just want to see what kind of things are available here. So you can pop bytes off the end, pop runes. So we don't have a concept of runes. You can grow it, destroy it. And toString. Oh, okay. So usually you would have this at the end, I guess. Not done. toStream. Oh, interesting. Oh, so they have the ability to write numbers into it. Interesting. Yeah. See, I guess the reason you would want this is because if you're encoding like an animation and you want to write a bunch of float32s into a file plus some other metadata, you don't want to have to like do a custom, like build half of it with like a string builder and then the other half with a binary number buildery thing, and then you want the numbers to just be the right way around. Do you guys know if float 16s are supported on most computers? I don't think they are, but it'd be cool if they are. So I don't think we really need 32-bit floats for a lot of stuff we do. Well, I'm going to see if we can write in a number somehow. So we're going to say string builder append u32. And we want this number to come out in the same order as we put it in. So let's put in this. Actually, we'll just put in 1, 2, 3, 4, I guess. So we probably need this and the number. So the number is going to be u32. All right. How are we going to do this? I don't know enough about casting, but the procedure is going to be basically exactly the same as this. In fact, we could probably do some like just swap the bytes in and then put it into a string literal or a string and then send it into this procedure here, but we don't want to do any allocation. So data equals buff we'll make this 5 long, initialize it with zeros, and I guess the easiest way to do this is to just shift the bytes. So buff 0 equals what would it be, n, and first byte shifted up by 4. I think that's correct. Now I need to do the second byte shifted up by 3. And then no, that's wrong. It's got to be 1, 2, 3. Yeah, 3, 2, 1, 0. Yeah, okay. Is that correct? I think it is. And then, but this is going to disappear. It's on the stack, and when this function is returned from, but that's fine, because we're not going to return from this function until after we call string builder append oops, just going to pass in s here, and the length is going to be 4. I think that will work. I hope so anyway. Let's have a look. Okay. Alright, we've got an S again. This time we've got buff. Let's just see to make sure this works. I'm not going to be able to see it in this format. Okay. So, what number did I put in there? What is 0x1234? What's the format specifier for this? 4660. Okay. So this is definitely incorrect. Fantastic. I could have just typed in N. Okay. What? Oh, I need to shift it back down. I need to shift it down, not up. Yeah. Oh, God. No, that doesn't make sense. Because this byte is going to be at the end. Okay. I need to reverse these. 0, 1, 2, 3. There we go. I think that's correct. Okay, let's have a look. Did we get it? 4660. No, we did not. What is 4660 in binary? Can we look at that? No, this is hex. 81624. Oh yeah. Yeah, totally. I'm shifting by like I thought I was shifting by bytes. This is shifting by bits. Right. Yeah. Thanks for that, Josh. Okay, let's have a look at that. Okay, what do we get? We're gonna look at this in hex. Yeah, 1, 2, 3, 4. Great. That's what I wanted. Let's just give it a bigger number. One, two, three, four, five, six, seven, 8. Excellent. Okay, now, does it actually get appended? Let's see. What have we got in here? We've got a string. Looks like this. What does this actually look like in the memory? Where are we? Here. 1, 2, 3, 4, 5, 6, 7, 8. Yay! This looks like it's gonna work. Yada yada yada. Okay, we've appended it. And we've added it to the permanent allocator. Let's have a look. Yep. 1, 2, 3, 4, 5, 6, 7, 8. Great. All right. We successfully made an append U32 function. I disconnected again. Okay, I think I'm going to call it there. It's getting late. It's past 10 p.m. My bedtime is usually around now. So I want to thank you guys for tuning in and helping me out. I think we did pretty well today. We got a string builder done. We can make strings, and we can also add integers to them, which is cool. And they come out little endian, which is what we wanted. Yeah, I'm going to call this a success, and next time I think we'll continue building what? String builder, done. Memory allocators, kind of done. I'm not sure, I'll think of something. Probably outputting text to the console. I think that's a pretty important thing. Although you probably noticed that we didn't use any printfs because we can't. But yeah. Alright, thanks guys, and I'll see you next time.